Hi, this is ISCI 344 Game Theory. My name is Rick, and my co-teacher who prepared these notes is Christoph. So today we're going to jump into things. This is our first class, and we're going to be talking about something called the Ultimatum Game. And our reason for talking about the Ultimatum Game is that we want to give you kind of a practical, applied introduction to game theory. And so this is a nice example where it's fabricated enough that you can see how game theory works, but applied enough that you could see how maybe it would work in the real world as well. So it strikes a nice balance there. Let's talk about what the Ultimatum Game is. Okay, so the essence of the problem is that some players, some individuals have to decide how to share some payoff. So we start with two players. Let's call them the proposer, and that's my funny backwards and symbol. Get used to it. And the responder. The challenge for them is to decide how to share a payoff. The term payoff is going to come up again and again. It's something you should learn what it is and put it in your glossary. For now, we can just think of it as a divisible commodity. The way the game works here is that the proposer and the responder take turns. First, the proposer presents an offer of a fraction of the payoff to the responder. Notice that the fraction is how much the proposer is offering to the responder. So if I'm the proposer, I might say, hey, I'll give you X%. And it's not how much they're keeping for themselves. It's how much they're going to offer to give. The responder, in turn, has a simpler choice. Well, maybe not simpler, but there are only two things that the responder can do. The responder can accept the offer or decline the offer. If the offer is accepted, then both players get their share. And what that means is that the responder gets the fraction that they were offered, and the proposer gets the remainder. If the offer is declined, however, then nobody gets anything. So, the role of game theory here is to figure out what happens. How much should the proposer offer? When should the responder accept or decline? And what is going to be the outcome of this scenario? Okay, so this is already a pretty complicated problem just because at this point the proposer can offer anything. They can offer 0%, 1%, well, any fraction even less than 1%, all the way up to 100%. And it can be anything in between there. So that makes it a little complicated and hard to figure out. So let's break this down. Let's simplify it so that the proposer only has two options. They can offer a high amount or a low amount. And we'll just leave those as variables where we don't know what they are, what the fractions high and low mean. But we know that, well, let me take a break and write this down and then tell you what high and low mean. And now we can talk about what high and low mean. So our only constraint here is going to be that low is more than nothing, but less than high, which is less than all of the thing. And that's all we have to say. So we could imagine a pie, and maybe the proposer offers most of the pie. That would be a high amount. Or in another scenario, the proposer offers a small fraction of the pie, and that would be a low amount. That's all you have to picture. A big portion of the pie or a little portion of the pie. Now, let's look at the responder in this scenario. So in this case, what we'll do is we'll simplify what the responder can do. Let's call this the first strategy, HO, which means that the responder accepts high offers only. High only. The other strategy we can call all. I think you can figure out what this means. Of course, these are only two of the four possibilities that the responder could choose. They could have strategies where they accept the low offer but not the high offer. But, if they care about this payoff, that would be a weird thing to do. And the last option would be to accept no offers. But again, that would be a little bit weird, and it would make for a pretty dull game. So we're going to exclude these two other options. Those are not allowed. Now, we've got two strategies for the proposer and two strategies for the responder. And the proposer goes first and then the responder responds, which makes it a really nice scenario where you can just kind of lay it out in a tree, a thing we call a decision tree, to decide what's going to happen in this game. Well, to see what might happen in this game. There's a lot of assumptions that we haven't gotten into that we will need to talk about before we really understand what game theory is. Let's talk about this thing, a decision tree. That would probably be a good term to have in your glossary as well. I'm going to draw it sideways. So we have time increasing towards the right. So we start at the starting time with the proposer making a choice. And the proposer really has two things they can do. They can make a high offer or they can make a low offer. Once they've made the offer, then the responder needs to decide what to do. And so a little bit later in time, we come to the choices of the responder. If the proposer has made a high offer, then the responder needs to respond to that high offer and decide what to do. And the responder's two choices we already discussed are high only or all. If the proposer makes a low offer, then again we need to decide what to do, and the responder's choices are high only or all, just like before. Now, let's look at what the payoffs are in this scenario. And the way we'll write them are, first put the payoff to the player who went first, the proposer, and then the payoff to the second player. In our case, that's the responder. So at the end of this scenario, we can see what the payoffs are under all of these cases. For example, if the proposer makes a high offer, again, remember this is the offer made to the responder, and the responder has a strategy of only accepting high offers, then the responder will accept this offer, which means the responder gets H, and the proposer, to be clear, the responder gets a fraction of the total, and that fraction is H. The proposer then gets the remainder, which is 1 minus H. If the proposer offers H and the responder accepts all, then it's easy. We already know it because the responder will accept this again and receive H, and the proposer will receive 1 minus H. On the other hand, if the proposer makes a low offer and the responder's strategy is to accept high only, then the responder is going to decline this offer. And if you recall, if the offer is declined, then nobody gets anything. See that? Nobody gets anything. So that means the proposer and the responder get 0. They lose out on this payoff. On the other hand, if the proposer makes a low offer and the responder says, I'll accept everything, then we get a scenario where the responder gets what they were offered, a low offer, and the proposer gets the remainder. So let's think a little bit about what the proposer and the responder would prefer in each of these cases. So the proposer wants the most they can get. And that happens, first of all, the offer has to be accepted. So it can't be a low offer with an HO response. But if the proposer makes a high offer, then they potentially could be losing out if the responder would have accepted all offers. So the proposer would like this 1 minus L because that's more than 1 minus H, and it's definitely more than 0. So the proposer...
Charge me, somebody.
Ignore that. That's just my tablet telling me she needs a charge. Okay, on the other hand, the responder would prefer to get the most they can. So in that case, we want to be looking at the second number here, which means H is best because it's more than L and definitely more than 0. So the responder prefers either of these top 2 outcomes. So the important ingredient here is that the proposer and responder prefer different outcomes. That's not essential to game theory. It's not a requirement, but when it does occur, it tends to make the game more interesting. Because it raises the problem of how do the 2 players decide what is the final outcome. So let's work through this and figure out how they do decide in this case. And the way we're going to do this is by analyzing the game backwards. We'll start by going forwards, then get to the end and work backwards to figure out what the result is. If that doesn't make sense, pay attention. So the first step in our analysis is to look at what the proposer does. So there's a few different options, and we should look at them independently. First, we can consider the case where the proposer makes a high offer. In that case, both strategies of the responder yield exactly the same outcome. And what that means is that the responder has no reason to discriminate between the 2 strategies. And by discriminate, I mean that the responder doesn't prefer one choice over the other. They're both equivalent in his or her perspective. In other words, the responder is indifferent to the choices available to him or her. Okay, let me point out a few more words that you'll want to pay attention to. Indifferent, meaning that the responder doesn't care, doesn't prefer one over the other. That should go in your glossary. And we keep using this word here, strategies. That's an important word in game theory, and you should make note of it. So that was the scenario if the proposer makes a high offer. What about if the proposer makes a low offer? In this case, the responder does have a preference because the result L is better than nothing. So the responder will prefer the strategy that gets him L, which was our accept all strategy. And that's because it yields a higher payoff. So based on that, the responder can decide what to do in advance before the proposer even makes a choice. In the first case, the proposer doesn't care, the responder doesn't care. In the second case, the responder prefers accept all. So the accept all strategy is a good choice in both cases. So we know what the responder will choose. Now, the proposer, being a rational, smart person, is going to reason the same way, and they'll conclude that the responder will choose accept all. So now the proposer has some insights into what the responder is going to do. Given that knowledge, can you imagine what the proposer will do? Yeah, if the proposer knows that the responder will accept all, they're going to offer a low amount. And that's just because their own payoff is better than, because 1 minus L is better than 1 minus H. So now we know, by working backwards, we figured out what the responder was going to do in any case, and then, given that, what the proposer should do, and so we know what the outcome is going to be. The outcome is going to be 1 minus L for the proposer and L for the responder, meaning that the proposer is going to offer low, and the responder accepts all. Okay, we sound pretty smart here, pretty confident. We know what the expected outcome is going to be, but this expected outcome relies on a couple of really important assumptions. So let's talk about those a little bit. Okay, one of our assumptions here is that higher payoffs are always preferred. What that means is that the payoffs accurately reflect the player's preferences. In the field of economics, the term payoffs is often replaced with the word utilities. And we won't get into what utilities are right now, but we will talk about it later in the course. But for now, you should just think of utilities as payoffs and make a note of them in your glossary. Another consequence of this assumption is that players are rational. That just means, in this case, that they make choices that help them maximize their payoffs. Okay, and again, rationality is a huge concept in game theory, and you should know what it means and be able to work with it. And this is a term that will come up again later. So another really important assumption in game theory and in the analysis that we just did is that players don't care about the other player's payoff. Only their own payoff matters to them. In fact, we can go even a little bit further than that. In general, it isn't even possible to compare payoffs between players. It's like apples and oranges. One player might be getting apples, the other player might be getting oranges, and you can't say, well, 2 apples is better than 1 orange, or vice versa, because they're different kinds of things. So one player's payoff might be measured in different kinds of units than the other player's payoff, and they might value these things differently. All you can compare is one player's payoffs for different choices that that player makes or other players make. But you can only compare payoffs within one player, outcomes for that one player. Okay, I think I've beaten that to death. But let me punch it home with another point, a related point. If players do care about the other player and what happens to that other player, then this would need to be reflected in a change to the other player's payoffs. This would need to be reflected in a change to the original player's payoffs or utilities, because it has to accurately reflect the preferences. So let's look at a scenario to try and make this a little bit clearer. Let's say, what do we say? Okay, let's say little Chrissy cares as much for his friend little Ricky as he does for himself. On the other hand, little Ricky is a rotten little bastard, and all he cares about is getting more than Chrissy. In fact, little Ricky only cares about the difference. Then, if they get a payoff, they each get a payoff. Let's call them PC for P Chrissy and PR for P Ricky, sorry, this is just a hypothetical person. Then they might value these things something like this. Maybe the utility for Chrissy might be maybe the total payoff that they both get, and it doesn't matter who it goes to. On the other hand, rotten little Ricky only cares about getting more, so all he cares about is the difference. How much more does he get than Chrissy? So in any kind of outcome in a game, you would have to translate these payoffs and these outcomes into utilities for these players according to this formula. And then those would be the utilities that are used to decide what strategies the players would use. Okay, that was just a little aside, and we can get back to the main point now. So, as I said, there were 2 key assumptions that we're using for our analysis, and I'll just review those one more time. That higher payoffs are always preferred, and secondly, players only care about their own payoffs. So I'm driving that home because these are kind of the foundational pillars of game theory, and they will be the basis for all subsequent discussions throughout the course. So we should keep those in mind. So there's just one last point I want to make before I stop with this lecture. And that is considering what is special about the outcome that we've arrived at. If there's anything special about it. And of course, this is all under the assumptions that we've already gone through. Okay, so to see what's special about them, let's consider the case where one of the players changes their strategy. So let's consider these things one at a time. First, let's look at what happens if the proposer changes their strategy. Their strategy was to offer low, so what if that changes to now offering a high amount? So low changes to high. Well, we're assuming that the other player doesn't change their strategy. They stick to what they were doing. The responder had a strategy of accept all, so they're going to still accept all. The proposer is going to offer a high amount, and so the responder will accept it, and the proposer will end up with a lower payoff. And that's because what was 1 minus L is now 1 minus H. H is more than L, so 1 minus H is less than 1 minus L. So the proposer gets a lower payoff if they choose to change their strategy. So the proposer has no incentive to switch away from the expected strategy. What about the responder? Okay, you go ahead and see if you can figure it out. Pause the video right now, and I will continue when you unpause. Okay, I presume you have paused and worked it all out for yourself. So what happens? The responder had a strategy of accept all, call that all, and they switch strategies. So now they switch to high only. The proposer, as we said before, the proposer now doesn't change their strategy. We're just looking at the case where one player changes their strategy. So that means the proposer was still offering low. Now the responder accepts high only, which means that the responder's payoff drops. It goes from L, that's what it was before, and now they get nothing. So again, the responder has no incentive to switch. And we're in a scenario here where no player can improve its payoff by unilaterally changing their strategy. Okay, a word to make sure you understand: unilaterally. It means one-sided. So only one player changes their strategy. And in that case, that is the case we had when we found this expected outcome, 1 minus L, comma L. And that, the special thing about that is the definition of something you might have heard of, something called the Nash equilibrium. Again, that's a very important concept. You're going to have to remember it, throw it in your glossary, make sure you understand it. The Nash equilibrium was discovered by this guy, John Nash, and they've made a movie about him, A Beautiful Mind. Good movie. Check it out. And of course, he won a Nobel Prize, I think, for this concept. So, Nash equilibrium, important point. Make a note of it. That's all I want to cover in today's lecture. So I'll sign off, and I'll see you again next time. Bye-bye.